Today in this video we will be dealing with the direction of the chemical reaction. So as we know that the chemical equilibrium constant was Kc. We have discussed that in detail. So the question arises that is Kc equal at all the reaction? No, Kc is not equal at all the reactions. In some reaction Kc is change, and in some reaction Kc is always change in every reaction, because the rate or the amount of the reactant and product in every reaction is very change. So that is why Kc is not constant all the time. So when we deal with the reversible reaction like the forward and the backward reaction, so we don't know that the direction of reactions means we don't know direction. In here direction is supposed to be known as Qc. Here when we don't know the rate of the forward reaction, so the constant will be used over this situation will be qc, and qc will it is likely, for example, here I'm giving you the example. Here at the reactant side it is 58, reactant is 58, and here at the product side this is 8. So how we will be knowing that to make this product into reactant again, as this is a reversible reaction, so what reaction will be required to make this 8 to 58? What reaction, what type of the reaction will be required? It can be either forward, it can be either reverse. So what direction will be required to make them both equal, to make this product 58 again? What direction will be required? So that direction we can predict it by the qc. Okay, we can predict it by qc. So qc is directly proportional to product. Always remember that reaction, if the reaction will be higher, so the qc will be higher, because it is directly proportional to product. So qc is known as the reaction quotient. What it is? It is the reaction quotient. Okay, it is a reaction quotient. It describes the direction. So we will be understanding some certain relation, like we will be comparing Kc with Qc now. Okay, we'll be comparing Kc with Qc. So if we compare Kc with Qc, so let me write over here that if Kc is equal to Qc, so the direction, the product concentration and the reactant concentration are equal, means both are stable in the system. What we can write? We can write both are stable. Okay, so now if the Qc, you can also write here Kc and Qc, probably both can be, but here in this situation Qc, when Qc is greater than Kc, so must keep this thing in your mind, that this reaction, when the Qc is greater than Kc, so in this situation the product will be decreasing, means the product will be, we write product upon reactant. We know that. Okay, product upon reactant. So in this situation the product will be decreasing and the formation of the reactant will be high. How? Like I'm writing here, for example, yes, here I'm writing Fe to F here. So if at this side, if the product will be decreasing, so what will be increasing? Reactant will be increasing, obviously, means product are converted into reactant. So when the product will decrease, so what will increase? Reactant, because it is a reversible reaction, and that reaction, like when the QC is greater than Kc, so that reaction will be known as what? That reaction will be known as reversible reaction. Okay, like in this direction the reaction is going, product are decreasing and the reactant are forming more and more, so that reaction is known as reversible reaction. No, like it is known as the reversible reaction. So like as you can see by the importance of QC, you can see like we have determined the direction of the reaction. We have determined the direction of the equation reaction. So here the reaction direction is reverse. Okay, on the other hand, if I could write that if QC is smaller than Kc, so what will happen? So there will be increase in the product. Okay, I'm writing here another example like N24. This is also a reversible reaction, 2NO2. So when the QC means the reactant, now here when the product is like higher, when the product is higher, okay, so then there will be the increase, like in this situation, the product formation will be high and the reactant will be low, means reactants are converted into product. So what, when the reactant are converted into product, so the product will be more and more, means we will be producing more and more product. So that reaction, that direction of the reaction, as you can see, that direction of the reaction is known as forward direction. I hope that is clear. That direction will be known as the forward direction. Okay, as the product are increasing and the reactants are like less, means reactant are more and more converting into product, so that is why that reaction, that direction of the reaction will be what? Will be none other but the forward reaction. Okay, I'm making the chart over here, like how you can predict, as we have discussed that if QC is high, if QC is high than Kc, means if QC is greater than Kc, so that reaction will be known as the reverse reaction. Now in this situation, if the QC and the Kc are equal, so that will be what? That will be the equilibrium condition. Sorry. that will be the equilibrium condition. Now here at this situation, if the QC is smaller than Kc, so the direction of the reaction will be what? We have discussed that. So the direction of the reaction will be forward reaction. What? Forward. QC is smaller than Kc. I hope that is clear in this video. Like that is clear.